Hi everyone, this should be a relatively short video. I wanted to talk briefly about spatial joins. And what a spatial join is we are asking the computer to join attributes from one feature to another based on a spatial relationship. The target features and the joined attributes from the joined features are written to the output feature class. What I mean by that is, let me go ahead and turn this off, turn all points on. So we've got our example still of grassland and chemical spills and everything. And what we want to ask the computer is, or let's say you're posed the question, you are the manager of this grassland area. And you have all these samples, the chemical spills, which these points represent, just as made up data, and somebody's going to ask you, what is the sum cost for cleanup within the grassland area? Now, one of the ways to answer this is with a spatial join. What you can go ahead and do is, and the shortcut process is, you have two files we're asking the question of, grassland and all points. And we're going to go ahead and join information from all points, such as, let's go back here, costs. All right. We want to know the sum costs of data that are within grassland area. What this will do is produce a brand new shapefile. But first we have to figure out a way joining grassland to points or points to grassland. Because grassland encompasses the points, we're going to go ahead and click on grassland. And conceptually, we are joining the point data here to the grassland file. So we have join. Now we have the join interface. There's a drop-down tab where you go join attributes from table and join data from another layer based on spatial location. That's what we're looking for with spatial join. Again, you have a choice which files you want to join, and we want to join all of our points. So when I asked you originally the question of what is the sum total of all the costs for cleanup at these points within the grassland area, you have these statistics that can be calculated. What we are looking for is sum, but if you read this carefully, it has each polygon will be given a summary of the numeric attributes of the points that fall inside of it. This can be done with multiple polygons, but in this example, our polygon is grassland. So if we had another one attached to it, it would sum it all individually for each section of the grassland polygon. The other options are each polygon will be given the attributes of the point that is closest to its boundary. Normally you don't see this one too often. And one of the major advantages to the spatial join, in my opinion, is it creates a new file. So if you happen to make a mistake, which isn't uncommon with joining data, you can just toss out this new file and make a new one after the fact. So we'll call this spatial join 1. And again, we're looking for the sum. So we go ahead and hit OK. Now we've got this exact same shapefile for the grassland polygon that is new. It is not the same one as this. But if we go ahead and let's say we open grassland, we have nothing. But with spatial join, we have a sum of everything. So the number of points under grassland is 434. We have the sum of chemical parts per million, which probably isn't really helpful. But at the last one we're looking for is the sum cost. So we have $1,418,312 in costs that have been summed up for all the locations that are underneath the grassland polygon. There are a few other applications for spatial joins, but I just wanted to broach the subject with this video. I believe that ends this one. We're going to go ahead and talk about geoprocessing functions in the next videos, such as clipping, intersects, dissolves, unions, merges, etc. Thanks.